Hello, my name is Wilder, a math, statistics, and quant tutor. Today, I will discuss with you the solution of two problems, one from GMAT and another from the GRE exam. So let's start with the problem from GMAT. So let's read it. The value of this entire fraction is how many times the value of 2 to the power of 17, of negative 17? Well, the question is how many times this is bigger than that. They are not asking how much greater this is with comparison with that. If that was the case, so we would apply negative here. We apply subtraction here. We will subtract this from that to calculate the value. But the thing here is how many times. So as it is how many times, so we have to divide this by that to see how many times this is greater than that. Or come to something like this is k times 2 to the power of negative 17. So you can say that this is k times bigger than that. Well, so let's evaluate this expression and see what we can. How can we compare that to 2 to the power of negative 17? As you know, GMAT, sorry, we are starting here with GMAT problem. GMAT doesn't allow calculator. As that happened, so calculating something like 2 to the power of negative 17 would be quite laborious if you try to do without calculator and impractical. Instead, you have to use some property here of exponentiation to solve the problem. What you can do in order to do that is that you can, as all of those numbers are powers of 2, you can collect a power of 2 on this expression. And what power of 2 can you put in evidence? In fact, you can put this one in evidence so that you can directly compare to 2 to negative 17. If you collect 2 to the negative 17, then you have, let's do this, 2 to the negative 17 bracket. By how much we have to multiply this number to get 2 to the power of negative 14. And then here we are using the property that when you have powers with the same base, you keep the base and add the exponents. You keep the base and add the exponents. Well, as one of the bases are, as one of the exponents are negative 17, that is sufficient. You multiply that by 2 to the power of what to make this 17 becomes a 14? A 3, because negative 17 plus 3 is negative 14. So here you can multiply 2 to the power of negative 17 by 2 cubed plus. Next one. Now you have to get a 2 to the power of negative 15. How can you do that? What is the number that you multiply here by 2 to the power of negative 17? So 2 to each exponent in order to have 2 to the power of negative 15. Oh, that would be 2. Since negative 17 plus 2 results in negative 15. So here will be 2 squared. Then the next one now, by this time is easy. Just say 2 to the power of negative 17 is just to multiply by 2 to the power of 1. And finally, here we have the same number, 2 to the power of negative 17, 2 to the power of 2 of negative 17 again. So you just have to multiply by 1 here. And you know that you have a division by 5 on top of all of that, at the bottom of all of that. Let's do this calculation. Let's see what we find. So 1, we have here 1. 2 to the power of 1 is 2. 2 squared is 2 times 2, 4. 2 cubed, 2 times 2 times 2, 3 times, so 8. If you add all of that, you have 8 plus 2 is 10, 4 plus 1 is 5. Oh, so you have 10 plus 5, you have 15. So there you have 15. Let me just continue from here. So that will be 2 to the power of negative 17 times 15. Let me put a bracket here to separate this. Times 15 divide by 5. 15 with 5 cancel each other, so we have 3 times 2 to the power of negative 17. So this whole expression is 3 times 2 to the power of negative 17. Oh, so answer is letter C. That expression is 3 times bigger than 2 to the power of negative 17. Let's continue with another question, this time from GRE. So here we have a question from GRE. In GRE, we are allowed to use calculator. So here we can use calculator for this to simulate the conditions that we have at the exam. Let's take a read on that. If you want to give this problem a try, you can pause and then we discuss it in a moment. Okay, let's read it. 2AB5 is a 4-digit number. When you have problems of digit number, you have to realize that this A, this B, this here doesn't this here doesn't is A times B. No, it's not that how you interpret that. This A is a digit, this B is a digit. So here you have for a 4-digit number, 2A, B. Let me just put like this here. 1, 2, 3, 4, because we have 4 digits. The first digit we know is 2. The last digit is 5. And then the middle digits here we don't know yet. So 2AB is a 4-digit number divisible by 25. Let's stop here. A number is divisible by 25 if it ends in what digits? Let's investigate that. 25 times 1 is 25. 25 times 2 is 50, times 3 is 75, times 4 is 100, and then if you continue here, the next one in line will be 125, plus another 25, you have 150, then 175, then 200, and so on. So here you continue 325, 350, as you can see, all the multiples of 25 ends in just 4 possibilities here, four alternatives. Or they end in 25, or they end in 50, 17, or 00. Here you see that the number ends in 5. Well, what are the possibilities? Or is this possibility a 2-5? Or is this possibility a 7-5? And here you don't need to use sophisticated. In fact, it is recommended that you don't use sophisticated math to solve the problem, because you have a time to solve it. You have the options in front of you. You can simply scan the options. Scan the option is something that I recommend that you always do. So you scan the options to see what you have available to solve the problem. You know that the answer is one of those. By the way, I am applying another strategy, another tactic here without mentioning. That is, instead of reading the question at once, I read in pieces, and then I read in pieces, and then I comprehend each piece once at a time. That is better than trying to understand the thing at a whole at once. Well, but continuing the reading, if the number formed from the two digits AB is a multiple of 13, then AB is equal to, you have those possibilities. You know that this here can just end in 25 or 75. So this digit here, the penultimate digit, must be either a 2 or a 7. So you go there and rule out the possibilities. By the way, you know that this is going to be the digit A, and this is going to be the digit B. Take a look here at the structure of the number. Is 2AB5. The AB is in the middle. So you know that the B is either 2 or 7. 10 cannot be, because the last digit, the digit that corresponds to B is 0. By the way, let's put here. First digit is A, second digit is B. 0 cannot be. Can it be 5? No, because it must be 2 or 7. So this one cannot be as well. Can it be 2? Oh, 2 can be. Can it be 5? No, cannot be 5. Can it be 5 again here? Oh, cannot be 5. Oh, just because of this, the problem is solved. We already have an answer. The answer must be C. Answer must be C, without doing any further calculation, without doing any sophisticated mathematical calculation here. Just understanding the problem and just understanding the consequence of what a multiple of 25 is, and how can we use the options that are in front of us to solve the problem. But let's just check, let's just double check this, because they say that AB must be a multiple of 13. Well, if this is the answer, 52, is 52 a multiple of 13? Let's investigate that. Let's see. 13 plus 13, that is 26. And 26 plus 26 is 52. So yes, 52 is a valid solution that really solves the problem. So this is the video that I would like to present for you, that shows how you can apply simple mathematics to solve the problems. How can you use the options that you have to solve the problem, break the problem in pieces, understand the consequence of each piece at a time. I hope you have enjoyed, and I hope that we can also study together. I hope to see you in class with our studies of either GRE, GMAT, or SAT. So see you soon. Have a good day. See you. Bye.